Alright, what is the IUPAC name for CuI2? First, we need to understand which elements are being used in this compound. If you're unsure, refer to the periodic table. Cu, I know, is copper, carrying a +2 charge usually. I is iodine, carrying a -1 charge. These two together, when balanced, create CuI2. Now, as a general rule, the "ide" suffix, IDE, indicates an element holding a negative charge, or at least a negative oxidation state, as seen in iodine holding a -1 charge. Now, we have copper 2, iodine -1. That means iodine will have the suffix added onto it, iodide. Well, ide, creating iodide. Copper remaining itself, holding its name, now creates copper iodide, the IUPAC name for CuI2. Number 2, what is the IUPAC formula for sodium iodide? Now, in order to find the IUPAC formula for sodium iodide, it's first found by finding the elements' abbreviations on the periodic table. Sodium being Na and having a +1 cation. And iodine being I, or iodide, having a -1 ion. Coming together to form a 1-to-1 ratio. When creating a 1-to-1 ratio, we don't need any subscripts. So now all we do is go Na, sodium, and iodide, I, creating sodium iodide, the IPAC formula. Alright, question number 3. Find the molar mass of sodium iodide, NaI. So, first, to find the molar mass, we multiply the average atomic mass in AMU of the element by the quantity, then add all elements' subtotals to find molar mass. So, in order to do this, we have to obviously find the average atomic mass of the element first. And we know sodium's average atomic mass is 22.99 AMU. And we then times that by 1, because that's its subscript. Next, we find iodine, the mass of iodine, 126.904 AMU, times 1 as its subscript. And then we add them together to find the molar mass. So 22.990 plus 126.904, because they're times 1, they remain the same, equal 149.894 AMU, the molar mass of NaI, or sodium iodine. Alright, so number 4, calculate the molarity of the sodium iodide solution. So, first what we need to do is review the numbers and what we've got in the solution. So we have 375 milliliters of a solution of sodium iodide with a mass percentage of 19.5% with a density of 1.09 grams per milliliter. Now first, to find the molarity, this is the basic equation that we're trying to get to. But of course, we don't have this particular information so far, so we have to use the information we're given. So, first, we have to find. So, 19.5% by mass, as seen here, we divide by grams. First, calculate the molar mass, which is 149.89 as seen in number 3, the last problem we just did. Okay, next, this is the series of steps that we want to do to get here. First, we do 19.5 grams of NaI over 100 gram solution times 1 mole of our molar mass. Now, these two easily enough cross out or cancel out each other. And now is when the density comes in. 1.09 grams divided by 1 milliliter. But as we're trying to get here, we need liters instead of milliliters. So we next need to do times 1,000 milliliters over 1 liter. Once we add all this up and multiply all this up and figure out this equation, it equals 1.42 molarity of NaI. Alright, question number 5. When the two solutions are combined, what is the concentration of the iodide ion in the new solution? So, I set up a nice little picture to be able to view 250 milliliters of the copper iodide is mixed with 375 milliliters of sodium iodide, creating a mixture of 625 milliliters. Now, this will be important when we get to one of the final steps. But the first step right now is to find the moles of iodide in each solution. So, I start out with the first solution containing 250 milliliters, times that in order to get the amount of liters by 10 to the negative 3 over 1 milliliter. And then what we do is we want to take our amount of moles that were given, so 0.650 moles of copper iodide divided by 1 liter of the solution, all canceling out so far. And then what we want to do is times it by the mole ratios. So right now we have 2 moles of iodide for every 1 mole of CuI2. And once we multiply all this together, we get 0.325 moles iodide from copper iodide. And next we want to take our other solution, which is 375 milliliters, and we're going to do the same thing. And we take our mole amount, because we aren't given that in the question prompt. But we did find this out in number 4, so we insert that there. 1.42 moles of sodium iodide divided by 1 liter, all canceling out, times the mole ratio again, 1 to 1 this time, as we see here. And we get 0.5325 moles of iodide from sodium iodide. Next, what we want to do is find the total moles of iodide, so we add those two together, getting 0.8575 moles iodide. Now, on to one of the last steps. What we want to do is find the molarity of iodide items. So we do our final number of moles of iodide divided by our solution in milliliters, 625 milliliters, times that by 1 divided by 10 to the negative third to find the amount of liters. This is milliliters. And our answer is 1.372 mole. Well, the molarity is 1.372 iodide. Our new solution contains 1.372 moles iodide in the new mixture. Thank you.